Hi, I'm Celso.
And I am Dominic. We are here to talk about ADI's power supply solutions for vehicle tracking systems.
In this webinar, we will talk about what a vehicle tracking system is and how it works.
We will also talk about the challenges in power supply design for these vehicle tracking systems and how ADI solutions can help in overcoming these challenges.
Let's get started.
A vehicle tracking system, or VTS, is typically installed on cars and trucks. It provides real-time information about the vehicle's speed, location, and direction using GPS. Vehicle tracking systems are typically used in fleet management for logistics. It helps logistic companies to easily monitor the delivered products, reduce fuel costs, and effectively schedule truck maintenance. It is also used in public transportation management, like public shuttle buses, by sending real-time scheduled information to commuters when the buses will arrive, and flag public transportation authorities who monitor the location of the buses. In some cases, these tracking systems can also be used by insurance services to help these services better understand the driving behavior and habits of their customers.
For a vehicle tracking system to work reliably, it needs to have a robust DC to DC power supply. A power supply must be designed to protect the systems from common fault conditions like load dump, cold crank, overcurrent, and reverse polarity. Also, in the absence of power coming from the vehicle, the system must be able to switch to backup battery to ensure continuous operation. Ultimately, an automotive power supply must comply to automotive standards, particularly to ISO 16750-2 and CISPR 25. This is where the ADVTS 4152 combo power supply from Analog Devices is of help.
ADVTS 4152 Combo Power Supply is a high-performance, integrated power supply solution and management. Designed for vehicle tracking systems using a suite of high-quality ICs from ADI. It is powered by an LT456-1, a surge stopper to protect electronic systems from high-voltage transients, an LT8609A, high-efficiency step-down regulator, and an LTC4040 battery power manager with high current step-up DC to DC regulator to back up the supply from a single-cell lithium-ion or lithium iron phosphate battery. When car battery power is available, the step-up regulator operates in reverse as a step-down battery charger. ADVTS 4152 is designed to easily integrate into your system for fast development and faster time to market.
ADVTS 4152 protects the system from surges up to 200 volts, has a reverse input protection, a seamless transition to backup battery support, ride through a cold crank event, overvoltage protection, overcurrent fault protection, EMI proven, and a pin-selectable backup battery charging.
ADVTS 4152 integrates three major blocks: fault protection and surge stopper, an efficient step-down regulator, and backup battery power manager. These three blocks work together to provide reliable and efficient power to downstream electronics like the actual VTS. It can operate across a wide range of input voltages with surge protection up to 200 volts.
LT456-1 surge stopper overvoltage protection regulator with inrush current limiter has the following features: stops high voltage surges, adjustable output clamp voltage, overcurrent protection, wide operation range from 4 volts to 80 volts, reverse input protection, adjustable fault timer, and a fault output indication. The LT8609A, which is a 42 volts, 3 ampere synchronous step-down regulator with 2.5 microampere quiescent current, has the following features: wide input voltage range of 3 volts to 42 volts, ultra-low quiescent current burst mode operation, high efficiency 2 MHz synchronous operation, 3 ampere maximum continuous output, fast minimum switch on time of 45 nanoseconds, adjustable and synchronizable 200 kHz to 2.2 MHz, spread spectrum frequency modulation for low EMI. LTC4040, a 2.5 ampere battery backup power manager, has the following features: a step-up backup supply and step-down battery charger, a 6.5 ampere switches for 2.5 ampere backup from 3.2 volts battery. Input current limit prioritizes load over charge current. Input disconnect switch isolates input during backup. Automatic seamless switch over to backup mode.
In a typical operation, the board takes 12 or 24 volts across its input and outputs 5 volts, 3 ampere to downstream loads.
Designing automotive power supply to handle high voltage transients can be challenging, as this would require the device to dissipate excess power while leaving the sensitive automotive electronics undamaged. Load dump is an example of these high voltage transients. It happens when the alternator disconnects from a car battery while being charged, causing a surge voltage. The ADBTS 4152 uses an LT4056-1 surge stopper to protect sensitive automotive electronics from this kind of transient condition. In our demo setup, we will simulate a load dump event by sending a pulse using a load dump generator across the board's inputs. A 1 ampere constant current load is simulated by a DC electronic load, and a LED light indicator shows whether the power is delivered to the load. The system's output is read across the output pin of LT4356-1 using an oscilloscope. Let's send a simulated surge across the input. The actual surge waveform is displayed in this channel, and it is reading a 105-volt surge that decays in 400 milliseconds. Observe that the voltage reading across the output is kept at 5 volts, shown here in this channel. Also, the LED light never turned off, indicating that the power was not interrupted. We can also see the LT4356-1 at work in this channel. Notice the flat region in the waveform, where the chip is regulating the voltage at our desired clamp voltage.
Now for BTS to function continuously, it must have a backup power supply with the address of car battery. The ADBTS 4152 has a high current, step-up, DC to DC regulator used to back up the supply from a single-cell lithium-ion or lithium-ion phosphate battery. The charging voltage can be configured according to the battery type via a user-selectable pin. While keeping the typical setup, we will simulate a brownout condition or a discharged battery in a point-blank condition by cutting the power supply across ADBTS 4152's input. An actual 12 volts car battery now supplies power to the board, while delivering a constant 5 volts output shown here in this channel. A lithium-ion battery is connected to the board's backup battery input and is used as auxiliary power during the brownout condition. As we disconnect the car battery from the input, observe how the LED light remains on, indicating uninterrupted power across the output. The LTC4040 chip was able to seamlessly switch over to backup battery and managed to keep the output voltage at 5 volts, as shown here in the output channel.
Protection against an overcurrent condition must also be considered in an automotive power supply's design to prevent failures in the downstream load and the power supply itself. ADVTS4152 has built-in protection against an overcurrent events caused by a short circuit. Our demo setup is still running in normal operation. The output of ADVTS4152 from a current probe is displayed at channel 1, and the output voltage displayed at channel 2. We will simulate an overcurrent event by shorting the output terminals of ADVTS4152. The LED light turned off, and the short circuit event caused the voltage and current outputs to drop. Now, we will remove the short circuit we created to see if ADVTS4152 still works. After the short circuit condition is removed, the LED lights turn on and the voltage across the output is restored at 5 volts with a current of 1 ampere. ADVTS4152 is undamaged even after a short circuit condition.
A reverse polarity happens when the power supply's input terminal are supplied with wrong polarity. This usually happens by accident and could cause severe damage to the downstream electronics if not taken care of. Using the same setup, we will simulate a reverse polarity event by connecting ADVTS4152's positive input terminal to our car battery supply ground and the board's negative input terminal to our car battery's 12-volt supply. ADVTS4152 switches over to backup battery power as we temporarily disconnect the power supply to swap their terminals. Even with a supply of negative 12 volts, as shown in channel 1, observe that the voltage reading across the output is kept at 5 volts, which is shown here in channel 2. Also notice how the LED light remained on, showing that the board is operating in backup battery power and was unaffected by the negative 12 volts applied across its input. ADVTS4152 can withstand reverse voltage up to negative 60 volts without damaging itself or the load.
An automotive power supply is required to pass the international standards ISO-16750-2 and CISPR25. ISO-16750-2 describe the potential environment stresses of electronic systems such as BTS in a vehicle. It specifies tests which simulate events like load dump, cold crank, and reverse voltage. ADVTS4152 was tested and passed the requirements listed in the table.
CISPR25 is a standard that regulates radiated and conductive emission for the protection of onboard receivers in a vehicle. To reduce EMI, ADVTS4152 has an EMI filter installed at the input side of LTH609 regulator. The chip also uses spread spectrum modulation for low EMI operation. The radiated EMI performance of ADVTS4152 is shown in the figure. The red lines are CISPR25 Class 5 radiated and conducted emission peak limits. It shows that ADVTS4152's emission is within the limits, thus passing the CISPR25 radiated and conducted EMI regulation. In conclusion, the ADVTS4152 combo power supply is a complete solution designed to solve problems in powering vehicle tracking systems.
The ADVTS4152 is designed to offer high-performance over-voltage protection, stable power supply regulation, and flexible backup power management.
Make reliable vehicle tracking systems and speed up time to market using the high-performance ADVTS combo power supply only from Analog Devices.
For more info, visit us at www.analog.com. Thanks.